Hello, I'm Simon Barner from Fortis Institute in Munich. In the first two parts of the tutorial, I presented to you how AutoFocus can be used to model the logical and technical architecture of mixed criticality systems. In this last part, I will explain to you how these models are used to support advanced design aid methods. The first method I would like to explain to you is a design space exploration based on genetic algorithms. It is used to compute a set of Pareto optimal deployments based on the logical and technical architecture provided by the designer, as well as a design specification model. If required by the design goals, a fault-tolerant version of the application architecture is generated by the algorithm that uses spatial and temporal replication based on the segregation methods provided by the execution platform. Generally speaking, the algorithm considers both objectives and constraints. Objectives are used to rate the quality of the solutions and therefore spans the Pareto space. Constraints are hard requirements that must be fulfilled by any solution. In the following, I will illustrate how this approach can be applied to the automatic cruise control example introduced in the first two parts of the tutorial. As mentioned before, the logical architecture consisting of the automatic cruise control component and the HMI components, as well as a model of the hardware and the virtualization platform, as well as a specification of the design objectives and constraints, are an input to the algorithm. In the example, a failure minimization and an energy minimization objective, as well as a deadline constraint between two components, is defined. After the exploration is finished, the user has the possibility to inspect the different solutions from the Pareto space. This also includes the time-triggered execution schedules that are computed in order to rate the different solutions. As previously mentioned, the tool is able to create fault-tolerant versions of the original application architecture that employs redundancy and therefore also includes voting components. The deployment editor can be used to inspect the computed mapping of the components of the logical architecture to the partitions of the hypervisor. In addition to the design space exploration, AutoFocus also provides additional design aid methods, such as a simulator for the logical architecture, model checkers that can be used to check if formalized requirements are met by a logical architecture, as well as a test case generator. Congratulations, you have finished the tutorial on the AutoFocus 3 toolset. In summary, AutoFocus is a seamless model-based development environment. That is, it employs models at all levels of abstractions and explicits the relations between these models. In addition to that, it provides advanced design aid methods, as for example the design space exploration illustrated before, that are based on these models. Why don't you get your own copy of AutoFocus 3? It is open source, and the source code as well as pre-built binaries for different operating systems can be downloaded at af3.fortis.org.